Okay, this is lesson 16.2. We're talking about exponents still and a couple of different properties with exponents. It starts on page 718 in your textbook. Well, the first one is the product of powers property. And it says to multiply powers with the same base, add their exponents. And it gives us the example 4 to the second power times 4 to the third power is the same as 4 to the second plus third, second power plus third power, 4 to the fifth power. But if we want to look at what that means, 4 to the second power times 4 to the third power, well, 4 to the second power means 4 times 4, and this is times, there's their times. 4 to the third power is 4 times 4 times 4. So if you look here, really we have 4 to the fifth power. So you look back up here, and all we had to do was add those two exponents, which is where they got the property from. If you ever forgot the property, we could just intuitively come up with that rule on our own. These are math rules that actually we could come up with on our own. Like I could have made that one. The second property is the power of a power property. And in words, that one says, to find the power of a power, multiply the exponents. And it gives us the example, 4 to the sixth power raised to the third power. Well, let's think of what this means. This really means 4 to the sixth power times 4 to the sixth power times 4 to the sixth power, because that's what that cubed means. Each thing in parentheses is multiplied by itself as a factor 3 times. Well, now we could just go back up to this property, the original powers property, the product of powers property, and just add these. We could look back here. That means we could have just multiplied these. But let's look at what this actually means. 4 to the sixth power is 4 times 4 times 4 times 4 times 4 times 4. 6 of those, times, I'll put a big times in there for that, it really means the same thing, 4 times 4 times 4 times 4 times 4 times 4, so that's for the second 4 to the sixth power, and then finally, for the third one, 4 times 4 times 4 times 4 times 4 times 4, and we look, and we add all those up, and we've got actually 18 4s there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this really equals 4 to the 18th power. And we go back, and that's why they said, really all we have to do is multiply these two. When a power is raised to a power, multiply those two. If you forget that rule, you can always just write out what it means and come up with the property all on your own. The third one is the power of a product property. And the third one, it says, to find the power of a product, find the power of each factor and multiply. So what that means is they have 3 times 2 raised to the fifth power is the same as 3 to the fifth power times 2 to the fifth power. And you can pull those apart. And you actually will use this quite a bit in algebra. So a lot of times one of these will have will be a variable. So if it was 3x to the fifth power, if this was in parentheses, it really means 3 to the fifth power and x to the fifth power. But here, if we wanted to prove this to ourselves, remember this is 3 times 2 to the fifth power would be 3 times 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3 times 2. And notice I have 5 times I wrote 3 times 2. 5 times. And now I can reorder these things, and I've got 5 3s there, so 3 to the fifth power, and 5 2s, so 2 to the fifth power. So those are the three properties we're going to talk about: product of powers, power of power, and power of a product. And let's look at the examples they gave us. So on the first example here, it says multiplying powers with the same base. So multiplying powers with the same base. And the first, so example 1A says 4, no it doesn't. It says 2 to the 4th power times 2 to the 5th power. And we know that we can just add those two up. And if we forgot that, we could really write 2 times 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 2. Add those all, and not add them up, but count how many there are. And you'd have 9 2's there all multiplied together. So this is really 2 to the 9th power. Remember, when we're multiplying powers of the same base, of course, then you just add those. But if you forgot that, you could just write it all out and figure out what it means. Another one that they give us for this example of multiplying powers with the same base is -5 times, and then they had to use parentheses here, -5 to the 6th power. Now remember, if something's not raised to a power, it's automatically understood to be the first power. So here we have -5 to the 1st power, -5 to the 6th power. Add those together and we get -5 to the 7th power. Don't forget this has to be in parentheses, keeping the negative snug with that 5. And finally, nice thing about these, we don't actually have to solve and figure out what that would actually be. Here we have x to the 3rd power times x to the 7th power. And using this same property, we know that this would actually just be x to the 10th power. Okay? Because it'd be x times 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 x. 1, 2, 3, 4, 5, 6, 7 of them. Count them all up, and it's x to the 10th power. Okay? Well, example 2 is finding a power of a power. So for example 2 here, A, it says 4, no, it doesn't again, darn. I did that in example 1. 3 to the 4th power raised to the 3rd power. And we really know that means 3 to the 4th power times 3 to the 4th power times 3 to the 4th power. So really, we would have 12 of the 12 threes, or we can just multiply those two. A power raised to a power, you multiply them. This is 3 to the 12th power. So now they give us an example with variables. Makes it a little more abstract for us, but not a big deal. And w to the 5th power to the 4th power, we multiply these two, and we would get w to the 20th power. Okay? Or we could write out all of our w's and see that that's what it would be. Finally, for example 3, and in example 3, we're talking about finding a power of a product. A gives us 2x in parentheses to the 3rd power. Without the parentheses, that 3 would just apply to the x. But because those are in parentheses, it's to each of them. This is the same as 2 to the 3rd power times x to the 3rd power. And 2 to the 3rd power, 2 times 2 is 4 times 2 is 8. So this equals 8x cubed. And this is probably more likely where you're going to see that kind of a thing in an algebra class. And the last one for our examples, B here, is 3xy squared. And that equals 3 squared times x squared times y squared. We know 3 squared, 3 times 3 is 9, so that gives us 9x squared y squared. And we don't have to have the multiplication in there because it's automatic because they're next to each other. Excellent. Well, now we can do the on your owns. Number 1, 6 squared times 6 to the 4th power. Okay, we're going to just add these up and get 6 to the 6th power. For number 2, we have -1/2 in parentheses cubed times -1/2 to the 6th. So don't get confused. I mean, you can just look at this is just whatever's in parentheses. It might as well just be a variable or just an integer. But it's a -1/2 to the 3rd power times -1/2 to the 6th power. Same rule. So we're just going to add those, and we have negative 1/2. Of course, the parentheses are important, to the 9th power. Number 3. For number 3, z, which means z to the 1st power, it's understood, times z to the 12th power, is z to the 13th power. Number 4, now we're getting into the powers of powers. So for number 4, we have 4 to the 4th raised to the 3rd. So 4 to the 4th raised to the 3rd. So we have 3 4 to the 4ths, which means we have 12 4s. So that equals 4 to the 12th power. And let's see, go down here. Number 5. Again, a power to a power, so y squared to the 4th. We multiply these two and we get y to the 8th power. For number 6, we have negative 4, has to be in parentheses, raised to the 3rd power, and that raised to the 2nd power. So a little confusing because look at parentheses and then a parentheses again, but don't just take it a little at a time here. Negative 4 to the 3rd power raised to the 2nd power, and we just multiply those two to get negative 4, still in parentheses, to the 6th power. Number 7, 5y to the 4th power is the same as 5 to the 4th power times y to the 4th power. Well, 5 to the 4th power, 5 to the 4th power, 5 times 5 times 5 times 5 is 625 times y to the 4th power. Number 8, ab to the 5th power is just a to the 5th, b to the 5th. And finally, on these on your own, number 9, we have 0.5 mn all squared, which is 0.5. And I'm going to put it in parentheses, although technically I don't think it has to be, squared times m squared times n squared. Well, 0.5 times 0.5 is 0.25 m squared n squared. Excellent. Well, now you can go over and watch the video for journal page 374 and then do the questions for these.
Fantastic.